right, welcome to our lesson on piecewise functions. Piecewise functions is defined by its name, pieces of at least equations, and we're going to graph those or evaluate those based on different domains, different places where they exist on the graph. The first thing we're going to do is to evaluate piecewise functions. We're going to choose which equation we use based on the x value or the input that we're asked to work with. And we're going to plug it into the equation based on the corresponding domain. Once we plug it in, we're just going to evaluate using the order of operations. So in example number, you'll see here we have a piecewise function. There are two pieces. There are two lines. The top line, 3x plus 2, only exists for the domain -2 to 0. And the bottom line, x minus 1, only exists for the domain 0 to 4. So the first value we're asked to find is x equals 0. So we need to figure out, based on the domain on the right, should we plug 0 into the equation or into the bottom equation? The 0 is included in the top, so we're going to plug 0 into the top equation and do 3 0 plus 2, which gives us 2. So when we plug in 0, we get 2. That's a point on the graph. The next value we're asked is 2. The next value we're asked to find is x equals 2. So we look at the domain and ask, does 2 fit between -2 and 0 on the top, or does it fit between 0 and 4 on the bottom? And it fits between 0 and 4. So we're going to put it into the bottom equation, 2 minus 1. So for this function, when we plug in 2, we get a value of 1. The last question asks us what to do with of 6. Well, 6 does not fit between -2 and 0, and 6 does not fit between 0 and 4. So it is not defined for our function. So this does not exist, which is a possibility as well. Simply is not on our graph. After we evaluate, we're going to end up graphing some piecewise function. And we're going to graph by first dividing into the parts of the domains we're given by doing just a vertical highlight, something that's not really part of our graph but shows us where we're going to change. Those are the change or the transitions. We're going to graph the first function and then get rid of what we don't need. So we are just going to be graphing lines today. So as long as you can graph a line, you're graphing a line and erasing. And then we have to figure out what's going to happen along those change values, those lines. We will have a closed circle if our domain has an equal sign with it, less than or equal to, greater than or equal to. We'll have open circles if we only have a less greater than symbol. So remember, open circles can only happen on a highlighted line. So here's our second example of the day. We graph this piecewise function. And we're first going to look at our transition values or our change values. And they're both at 3. So I'm going to use my highlight tool to go over to 3 and draw a vertical line at 3. We're going to switch from one graph to the other. So one of the ways we can graph these is to look at the first graph, which is 2/3 x plus 2, and recognize that its slope is 2/3 and its y-intercept is -2. So to graph this function, I would go to -2 and count up to and over 3, and down to the left 3. And we could keep going. Up to the right 3 would put us over here. Now, if we look at the domain, it says, draw this graph where x is less than or equal to 3. There's our transition value in the green. We want to be less than 3. So we do not need this point over here. We're rid of that. And the line is only going to exist to the left of our transition value. But it's asking us this line to always decide on a solid or a closed circle. At our transition, we see an equal sign there, so I'm going to emphasize this. This is a closed circle because it says equal to 3. The second equation that I will do here in purple is negative x plus 1. The slope is negative 1 over 1, and its b value, or intercept, is 1. So even though I know my isn't going to be on this side of the highlighted line, I'm going to use what I know about the graph to draw it correctly. So the intercept is 1, the slope is down 1 over 1. So with the purple dots, I can see where my graph goes. Now, if we look at the domain, it says this graph should only exist where x values are greater than 3, to the right of 3. So I only want this part of the graph here. I'm going to erase my other points because I don't need those. And we're going to ask, should this be an circle or a closed circle at the highlighted line? There's no equal sign, so this is an open circle. And this is what our final graph should look like. We have 2 lines, one to the left of 3 and one to the right of 3. Once we've graphed that, we want to state the domain, which is looking left and right along the graph. And of course, we can see that this graph goes to negative and positive infinity. So we could either say x is all reals, or negative infinity to positive infinity. When we look at the range, we're looking up and down. And our graph goes to negative infinity, but the highest value is up here at a y value of 0, right here. So our range in set notation is y is less than or equal to 0. We can say, in terms of range, our graph goes from negative infinity to 0 in interval notation. So here's another graph that looks more complicated, but it should be relatively easy to graph if we understand what each of these lines is. We have a lot of transition values, -4, -2, 0, 2, and 4. So at each one of those, we are going to draw a vertical line at each transition. Sorry, I want to use the highlight tool for that. Make it a little wider. There we go. So that's at -4. We change again at -2, and at 0, and at 2, and at 4. Remember, each one of those is asking, should you draw an open or a closed circle? The first graph I'll draw, which is just the 1, is the same as saying y equals 1. That is a horizontal line at 1, and it should run between -4 and -2, according to the domain. So that graph will be right here. At each end, we have to decide open or closed. There's an equal sign at the -4, so that is closed. There's an open circle at -2, become equal sign. The next graph that we see is like saying y equals 2, and it goes between -2 and 0. So y equals 2 is a straight line. At 2, there's an equal sign, so we do the closed circle. And over here, an open circle because 0 is not included, no equal sign. Then we're on to y equals 3. Do that one in purple. Runs between 0 and 2. So at 3, we're going to include 0 because of the equal sign, an open circle at 2 because there is no equal sign. And then our last equation is saying y equals 4, our horizontal line at 4, between 2 and 4, so right here. And again, closed at 2 where the equal sign is, and open at 4. Our domain, if we look left to right, extends from -4 on the left to 4 on the right, but you'll notice there's a solid circle at -4, open circle at 4. The range is just a y value of 1, a y value of 2, a y value of 3, and a y value of 4, so we are simply to list those as 1, 2, 3, 4, and the best way to do that would be set notation, because it's just those specific 4 values. So this is the only time that the range is a list of numbers when we have this step function. All right, and our last example is going to have 3 different graphs on it. We're going to have a diagonal graph, another diagonal graph, and then a horizontal line. So we'll do those in different colors, but first we'll start with our highlights for our transition values. The first transition value is at negative, and then our next graph goes from -2 to 1, so I'll put a vertical line at 1, and then our next graph is just to the right of 1. So those are our transition values. I will do the first graph in blue, which is y equals -1/2 x plus 2. So we know by looking at that equation, the slope is -1/2 and the intercept is -2. So remember, we're going to do some erasing. That's fine. I'm going to start at the intercept of -2, and the slope says go down 1 over 2, down over 2. So we think about connecting those dots and we can see that has a negative slope. But this line only is where x is less than or equal to -2. That's to the left of our transition line. So I only want this part of the graph right here. Every time you hit a highlight, ask should it be closed or open? This has an equal sign, so we want to close that off right there. And essentially, we just don't need the rest of those points. Our next line, I'll do that one in purple, which is y equals x. That tells us that our slope is 1 and our b value is 0. So I'm going to start by putting my dot at 0. I'm going to go up 1 over 1, up 1 over 1, till we get our pattern there. And this graph belongs between -2 and 1, between our transition points. So right here, the only piece of the line we need to see. Both of those inequalities are without equal signs, so every time we hit a transition line, we should have an open circle. And the last line, I will graph that one in orange, is y equals 2. That is simply a horizontal line. And we can see that that only exists to the right of 1. So to the right side of this transition line, I'm going to go ahead and draw that horizontal line. At our transition value, there's an equal sign, so we should have a solid circle. And then that would keep on going. So those are our 3 graphs. Our domain, we extend to -infinity and positive infinity. So we're going to say that our domain is all real numbers, or negative to positive infinity. When it comes to range, we're looking lowest to highest. And on this graph, our lowest point is right here, which is at -2, but it's not included. And then we continue to go upwards positive infinity. So we could say y is greater than -2, or we could say -2 to positive infinity. And you'll notice that there's no equal sign and no closed bracket because that was an open circle. The last thing we have to do with piecewise functions is go from the graph to the function. And this is going to rely on being able to write the equation of the graph. So we're always going to use our function notation and then a set of brackets. We're going to have 2 different functions here because we have 2 different lines. And if you like the highlight method, see here is our transition point. So that's going to tell us what our domain is. The first thing we're going to do is write the equation of the graph on the left. I'm going to highlight that in blue. And for that graph, we can see the y-intercept is -2. And we could count the slope between 2 points. Make that triangle and go down 2 over 1. So our slope is -2. So the equation of the first line is negative 2x minus. Now that line is only to the left of our green transition value, which is an x value of, put the domain next to it, that is x less than or equal to 1. The equal sign because there's a solid right there. Now our next line, which I will highlight in red, is just a horizontal line. So that's really easy to write. It is simply a number, and that number is 4. Y equals 4. That is only to the right of our transition value, and there's an open circle, so we say x greater than 1. Now, when we get to this last example, it is a piecewise. It's going to have 3 different graphs, 3 different lines, so we'll write 3 different equations, and we have 2 transition points. We have one here at negative 3, and we have another one here at 1. So let's go and look at the graph on the left, which I will do in blue, this first graph here. We can see that has a negative slope of down to over 3. So the slope is negative 2/3, but we can't see its intercept. So what we're going to do is we're just going to continue with that slope until we know what the intercept is. So I'm going to go down to and over 3. I'm going to extend that line. And I can see that if I had drawn the whole thing, the intercept would be negative 7. So our graph is negative 2/3 x minus 7. That graph is to the left and only the left of negative 3. And there's a solid dot at the value of negative 3, so x is less than or equal to negative 3. The next line I'll do in purple. It's this line with a positive slope. We could count the slope by going between 2 points. It looks like up 1 over 1. So our slope for that line is 1. Our intercept, we can see it crosses the y-axis at 1. So the equation of that line in the middle is 1x plus 1. It goes between negative 3 and 1. So x between negative 3 and 1. It is greater than or equal to negative 3, but it is less than 1. There is a solid dot on the left and an open circle on the right. And our last line that I will highlight in orange is a horizontal line. That's great. Those are easy to write. Just 8, y equals 8. And the domain of that line is everything to the right of 1. So greater than 1, and we can see there's a solid circle there. So we should use the equal sign.